busy roads. These could all be things of the past. The Ohio State University is working to solve these problems by developing smart cars and automated highway technology. In the future, automated highways and smart cars will reduce the number of accidents, make our highways more efficient, and reduce other problems associated with driving. In a period where the amount of traffic is steadily on the rise, this is important technology.
Intelligent Transportation Systems, or ITS as it is named, is the name we give to the total effort in providing solutions to mobility problems using control and computers and communication technology for taking goods and human beings from one place to another in a safe and efficient way, and in a way that will keep all the human beings and the users happy. Now, one of the efforts in this area is in automated highway systems, and automated highway system implies in a fully deployed state that you basically get in your car and maybe say Cleveland, and off goes the car, and you'll be told when you're approaching Cleveland to take the controls again. That, of course, is somewhat in the future. What we are now doing is seeing what the present-day technology is and what the present-day research is and how we'll be getting there. Now, Ohio State University has had many years of research and development efforts using its mission in education and research through the years, where it has contributed to the development of these technologies. Indeed, automated highway systems has been in the foreground of research here at Ohio State University many years ago. As long as 20 years ago, we were developing these things. And today we have a concentrated, coordinated effort going on, ranging from GPS to truck convoying. But one of the most exciting things, apart from GPS and truck convoying and automotive control, is our effort in automating cars. And in this, we certainly have had many successes and have been working towards the demonstration coming up in San Diego. The idea here is that we can automate cars to drive on their own and pass each other and go down the highway, and that will allow hands-off and feet-off driving, and it will be safe, and it will be efficient, and it will be fast. We have been working with Honda cars supplied by Honda to us, and a lot of different technologies have gone into our efforts. One of the technologies required for any such automated driving is, of course, sensor technologies. How do you sense the road, and how do you tell the cars which way to drive? The unique technology that Ohio State has been using in this is a radar-based stripe.
One of the technologies that OSU is demonstrating is a radar reflective stripe. It was designed at the Electroscience Lab. The radar in this vehicle is used for lateral control. The basis for that is this stripe, which is laid out in the center of the lane. This is a piece of standard 3M highway marking tape that has been modified using a pattern that we designed. Standard tape has sticky backing, just like this one. It has a sheet of aluminum and then a white opaque layer on top. For this prototype, we've used a clear layer, and we've also punched a specific hole pattern into the aluminum layer. The combination of the shape and the spacing of these slots that are punched into the pattern provide a strong backscattered radar signal that the car receives and used for left-right positioning.
We have a radar stripe ahead of us on the ground and a radar mounted in the bumper, and we can use that to measure where we are in the lane and control the steering. And in fact, we're controlling the steering now. No hands on the wheel, no feet on the accelerator. We're accelerating up to 45 miles per hour.
The trunk of the car houses the electronics that are needed to operate the car automatically. An Autobox system provides the main control for the system. It works in conjunction with other onboard computers to provide steering, braking, and other control functions. A display controller is also part of the system. It is used to drive monitors in the headrest and in the dashboard of the car. Radar transmitters and receivers are installed in the car's front bumper and on the side panels. The radar devices are used to keep the car on the road and sense other traffic around the vehicle.
We use the side-looking radars to make sure we're past a vehicle in the other lane so that we can merge back into the main automated lane. The FCC has recently allocated a frequency of 77 gigahertz for production use of systems like this in the United States. That means that this system we're working with is a scale model of the final system that will eventually be used. The final system should be 1/7 the size of this system that we're using today.
The Ohio State University has also developed vision technology for vehicle control. The vision system works with the radar system and provides an additional method for controlling the vehicle.
The way the vision system works, there's a single camera, much like the camera in a camcorder, a CCD type camera mounted where the rear view mirror would be up behind the windshield, and there's cabling to a computer system in the back. The camera is acquiring images of the roadway ahead. The computer system runs software that we have developed that extracts from those images bright lines against a darker background, which is exactly the way the road markings look on the highway. It extracts those, detects those lines, and fits a smooth curve through them, computes the center line of the lane, and transmits that information to the control computer so that it can adjust the vehicle's position in a lane and keep it following the roadway.
Now the vision is controlling the steering. This is what the vision sees. Basically, you can see that it's throwing, it throws on these blocks and these lines to indicate that it's found lane markers, and also draws in a virtual center line for the road.
The automated highway systems that are being developed at The Ohio State University will lead the nation into the future. Automated highway systems will make our highways safer and relieve congestion in urban areas.
Of course, in addition to the radar and the vision system is the control system that wraps the loop around all of these and actually steers the car and makes it run and makes the car follow the one in front, adjusts the speeds, adjusts the brakes for you. And we have done a lot in developing techniques and technologies and algorithms to develop these aspects. When the loop is closed, you will be out of the loop. There'll be hands off and feet off, and you'll get a smooth, safe ride in the cars that you have been seeing. Now, the work that we have been doing in automated highway systems and the technologies and techniques have been receiving attention. In fact, the National Automated Highway Systems Consortium, which has been given the task of providing a demonstration of present-day technologies in August in San Diego, has invited us to participate together with 6 other teams in this demonstration. In fact, we as a university are the only university who, as an associate member of this consortium, that has been invited to take part and have a full scenario there. What we will have in this demonstration is 3 automated cars. The cars in their basics have been provided to us by Honda, and we have put in both our sensor technology but also our control techniques, our control algorithms, and a lot of work by students and staff and faculty in providing a full scenario of cars going down the road, passing each other, getting back into lanes, slowing down, speeding up, or even stopping on the road, totally automatic. And you'll be seeing this on I-15 in San Diego in August during the '97 demo.